Question 6. Figure 8 shows how electricity is supplied to consumers by the national grid. So you can see here they've given us a picture of the national grid. Now in this case there are three main components that we have to be aware of. The first one is transformer X, and you've got the transmission cables, and you've got transformer Y. Now transformer X is used to increase efficiency of the process, whereas transformer Y is used to make energy safer for consumers. That's the main thing that you have to keep in mind. Now let's see, the first part says explain why transformer X is used in national grid. The question is about transformer X and its 4 markers. So basically we have to tell them what does transformer X do that increases the efficiency of the process. So we'll have to say transformer X, it increases voltage and reduces current. You have to remember, for a transformer we assume that it is 100% efficient, so the amount of electrical energy that goes in is equal to the amount of energy that comes out. Then we can say lower current means there'll be less thermal energy losses in transmission cables. Low current means less thermal energy losses in transmission cables. When I say low current means less thermal energy losses in the transmission cables, I'm trying to say here, if you use lower current, then there will be less heating effect in the cables. And if there is less heating effect in the cables, and that means less energy will be lost into the surrounding as thermal energy. Therefore, efficiency goes up. Next part says explain why transformer Y is used in the national grid. I've already told you it makes energy safer for the consumers. So for this, what we'll say is transformer Y, what it does is it will lower voltage and it will increase current. Now why is it that we have to lower the voltage? We have to give a reason. It says explain, so we'll say because high voltage is dangerous, making it safe for consumers. Now the last part of this question says the town of Hornsdale in Australia has electricity supplied by a huge battery. On one day, the battery transferred 3.24 times 10 to the power of 11 joules of energy to the town. So this is the amount of energy that was supplied, and it was on one day, so that's my time. The potential difference of the town's electricity supply is 230 volt. This is my V. Calculate the charge flow to the town on this day. It says calculate the charge flow. This means we do not know the value of Q. It says use the physics equation sheet. Now in this case, it does say use the physics equation sheet, because when this paper was done by students, they were provided with equation sheet. In your case, you will not be given any equation sheet with these formulas, so you'll have to memorize this formula. So there's an equation that links Q, E, and V, and that equation is potential difference is energy transferred per unit charge. Once I've identified this equation, all I have to do is I have to plug in the values, and once I plug in the values, I'll end up with the answer. So instead of V, I'll write down 230 equals For E, I will write down 3.24 times 10 to the power of 11. And for Q, I'll leave it as it is. One more thing that you have to keep in mind is you must give your answer to 3 significant figures. Now to solve this equation, you can simplify it for yourself. You can put 1 in the denominator and you can cross multiply. If you cross multiply them, you'll end up with 230 times Q equals 3.24 times 10 to the power of 11. Then you divide both sides by 230. This is gone. On the right side, if you plug these values in your calculator, you'll end up with a value of 1410 and then 6 zeros. This is the value of charge. Now remind yourself the unit for the charge is coulombs, which is C.